Okay, so back, there was some glitch or something. Camera turned off. I'm sorry about that. So for a particular x value, the radius is this. For any point, for any particular value of x, this is the height or the radius away from this point to the axis of rotation. So that will be nothing else but, in terms of x, of course, nothing else but y. So then we have negative x squared plus 6x minus 8, everything squared. The calculations are quite extensive here. After you square this trinomial, let me see what I got. I got the integral from 2 to 4, from x to the fourth minus 12x to the third plus 52x squared minus 96x plus 64 and dx. And after, again, a lot of arithmetic calculations, please work on those if you'd like. 16 pi divided by 15. Good. So now let's look into other examples. So be careful. The method of shells cannot always be applied, and also the method of discs or washers cannot always be applied. So you saw the difference here. Okay, moving on. Let's look at other problems. And I would like to look at 25 on page 465, in which we are given y equals x cubed, y equals 8, x equals 0, and we are rotating about x equals 3. Okay. Good. So let's graph. So x cubed, y equals 8, 2, 4, 6, 8. That's y equals 8. That's done. X equals 0. Of course, that's done. And now we want to graph y cubed. Y equals x cubed. And I know that when x is 2, y will be 8. So I'm going to graph accordingly. So this is y equals x cubed. So I already took care of the intersection. So this is the area in question. They're asking us to rotate it about x equals 3. So this is 2. Here is x equals 3. So then on the other side of x equals 3, will be something like this. And here is the solid when we rotate this area. And so on and so forth. Good. For the method of cylindrical shells, when we are rotating with respect to a vertical axis, we integrate with respect to y, not we integrate with respect to y, not with respect to x, not with respect to y. So then the volume will be 2 pi, the integral, radius, height, dx. So through the area, since we are integrating with x, for a particular x value, picture, for this particular piece, we have to determine the radius, and we have to determine its height. The radius will go here, the height will go here. It doesn't matter if you replace if you reverse them. It's a product. It's commutative. So the radius for this piece, for any x value, the radius will be 3 minus x. So the And of course, this is between 0 and 2, where the area is. The area is between 0 and 2. Good. So now let's see how we determine the height. How do I get this height? Well, the height is obtained from by subtracting from 8 this piece. So this is 8 minus. Well, but this is the y value. For this particular x, this is the y value for the function. So the y value is x cubed. So 8 minus 8 minus x cubed will give us the height. From this moment on, the rest is easy. So we have 2 pi, the integral from 0 to 2, I will distribute 24 minus 8x minus 3x cubed plus x to the 4th dx. And of course, 2 pi 24x minus 8x squared over 2 minus 3 x to the 4th over 4 plus x to the 5th over 5, of course, from 0 to 2. Luckily, I only have to plug in 2 in all this mess, because when I plug in 0 is 0. So 2 pi, 48, 4 times 4, minus, so 16 over 4, 4 times 3, negative 12. And this is positive 32 divided by 5. And let's see what I got towards the end. 264 pi divided by 5. Okay, so you can continue calculating those. And I'd like to present basically, yes, 2 more. Okay, so let's take a look. So let's look at next problem. Yes, 29. 29 is on the same page, 465. And here we have x equals 2y squared, x equals 2, about y equals 2. Good, so we are also told that we should only look at the positive side of y. Fine. Okay, so let's graph. About y equals 2. So first of all, x equals 2. Y equals 2. Which I really don't want it to be a solid line. Sorry about that. Okay, done. And x equals 2y squared. So let's talk about x equals 2y squared. This is a conic section, not a function. A parabola, but not a function. So when x is 0, of course y is 0, so 0, 0. And let's see what happens when x is 2. Why I made x 2? Because it's easy to simplify. So 2 equals 2y squared, or y squared equals 1, or y equals plus or minus 1. We have to be careful. However, I needed to graph it. So let's see. It goes through 0, 0. It goes through for x equals 2. It goes through positive 1 and negative 1. We only want the positive side. So the other side is not important because of this condition, only y positive. So this is x equals 2y squared. So we are looking at, first of all, the area enclosed by x equals 2 and this conic section, which should be this whole thing. but we are only asked to use the positive y values. Okay, now we are told to rotate this area about y equals 2. Okay, fine. So then the area will be, the reflected area will be something like this. And we are rotating and rotating and rotating. When we use cylindrical shells, when we rotate with respect to a horizontal axis, we integrate with respect to y. So I'll get the volume started. 2 pi, the integral from 0 to 1. We are talking about the area with respect to y. 0 to 1, radius, height, dy. Since we are integrating with respect to y, we will say this. For a particular y value, I picture the rectangle. I have to determine the radius, and I have to determine the height. Sorry, the radius is here. So this is for a particular y value. I need to determine the radius because we are rotating with respect to y equals 2. Always put the sign here so you don't get confused. So you can see exactly how we are rotating, or where we are rotating, about what we are rotating. Okay? So you can correctly identify the radius. So the radius is between the graphed little rectangle and the axis. And this is for a particular y value. And this is the height of the piece. Okay. So obviously, the radius is easy to determine because it's 2 units minus the y value. So that is clear. Now we want to determine the height. So we want to determine the height of this rectangle, this generic piece. Okay, how do I determine the height? Okay, the height will be, also remember this is 2. So the height is 2 units minus x for that particular y value. So this is the x. So the height will be 2 units minus x, but I cannot write 2 minus x here because we're talking about y. I cannot have y and x in an integral with the dy. But I know that x is 2y squared. So this height will be 2 units minus x, which is 2y squared. So times 2 minus 2y squared. Therefore, we have 2 pi, the integral from 0 to 1. I will distribute. I should have factored out the 2 to make it easier, but that's okay. So this is 4 minus 2y minus 4y squared and plus 2y to the third dy. So this is 2 pi 4y minus 2y squared over 2 minus 4y cubed over 3 and plus 2y to the fourth over 4. And luckily, I only have to plug in 1. So let's see what we get when we plug in 1. So that's my page 6. So 2 pi 4 minus 1 minus 4/3 and plus 1/2. I performed these calculations and I got 13 pi divided by 3. Of course, units, whatever units cubed. Final problem that I would like to present to you is problem 19, because we have a few things to talk about there. So in 19, last one from this section, on 465, we are given x equals 1 plus y minus 2 squared. We are given x equals 2, and we're asked to rotate about the x-axis. Well, In this particular case, we want to look at graphing this parabola, which is again a conic section. Parabola, not a function. Okay, so let's discuss that first. I hope you remember from algebra that for a quadratic function that is given to us like this in the completed square format, we know that the vertex of this parabola is h comma k. This situation is when we have x equals a y minus h squared and plus k, the vertex will be x comma y. So this will be k comma h. So the vertex in this situation will be 1 comma 2. Also, we need other points, right? X and y intercepts. So when x is 0, that's not going to be possible because I have y plus 2 squared equals -1. Not real. Now when y is 0, then we have x is -2 squared, which is 4. 4 plus 1 is 5. So we have 5 comma 0. So let's graph this parabola, which is a conic section. Okay. The vertex, 1 comma 2. 1, 2, 3, 4, 5. Axis of symmetry. So y equals 2 is the axis of symmetry. And how do I know that? It's because this is the vertex and it crosses here. Can I find another point? Right here. Exactly 2 units away from the axis of symmetry. And here is the conic section in question. Oops, missed it a little bit, sorry. So this is x equals 1 plus y minus 2 squared. We graph the parabola, the conic section. Now x equals 2. Here is x equals 2. And they're telling us to rotate this area about the x-axis. Don't forget to put the symbol so you don't get lost. Okay, so in that case, here is the corresponding mirror image. And here's how we are rotating and rotating and rotating. As we know, using the method of cylindrical shells, when we rotate with respect to a horizontal axis, we integrate with respect to y. Okay, so then seven. So 2 pi, the integral from the area. The area is between 1 and 3. Between 1 and 3. And we have radius, height, dy. Like before, we always have to say we are integrating with respect to y for a particular y value through the area. Since we are rotating with respect to x, in this case, this is the same with the radius. And we picture the little rectangle. We have to determine its radius, and we have to determine its height. Radius is just y. No problem there. What about height? So the height is, again, 2 units minus the x value corresponding to that y value. So y, x. But I cannot write in here 2 minus x. I should write 2 minus x. I cannot. But instead of x, I will put that. So I have 2 minus 1 minus y minus 2, everything squared. I'm going to erase this. Just I don't want you to get confused. It's not 2 minus x. I have to replace x by what x equals to. We cannot have x and y in the same integral. So from this point on, everything is just, it reduces to solving this definite integral. So I have y, 2 minus 1 minus y squared plus 4y and minus 4 dy. So this is, oh, look at that. Thank you for your patience. Okay, so 2 pi, the integral from 1 to 3. This is one, let me write it one more time. So negative y squared plus 4y, and 2 minus 1 is 1 minus 3. Okay, 1 to 3, negative y to the third plus 4y squared minus 3y dy. And this is 2 pi. And then we have negative y to the fourth over 4 plus 4/3 y to the third minus 3y squared over 2 from 1 to 3. And I did perform all these calculations, and I got 16 pi divided by 3. Thank you very much.